my name is Taylor and welcome to our first episode of Getting Started with CEM102, where we will be demonstrating everything you need to know to get started developing with onsemi's analog front-end device designed for low-power electrochemical sensing for applications like continuous glucose monitoring. In today's video, we'll be unpackaging one of our demonstration boards and take a look at what we can expect from it right out of the box. Let's get started. Okay, so let's start by getting our board fresh out of the package. Now we have paired the CEM102 up with the RSL15 Bluetooth microcontroller. This way we have a nice way to interface with it and provide some sample applications. So right here in the middle is the RSL15 and below it is the CEM102. We have a push button up here for the reset as well as a user I/O. Then over on the side, we have a breakaway section here. This is to interface with the RSL15. So we have a typical 10-pin JTAG header and 4 GPIOs here. We have an additional 2 down here for a UART interface, and then the power header is broken out here. Now, so this whole section can be snapped away, and we do still have a 6-pin JTAG connect interface to connect to the RSL15. Now below it, likewise, we have the CEM102 section with the 2 working electrodes as well as a reference and counter electrode and a ground reference here too. There are also 2 IOs that are connected directly to the CEM102 that are broken out here. And again, this whole section can be broken away, but the 4 electrodes are all still available here on these test pads. Now there is also a jumper here, and this is just a way to isolate power for the CEM102 if you want to measure the power consumed by it alone versus the entire system. On the back, we have a spot for a 12mm coin cell battery, which can take 1.5 volt cell by default or be reconfigured for 3.3. Now, along with the demo board, we have included a sensor emulation board. This can be connected to the CEM102 and used to simulate a variety of different sensors. So we have some pads here where you could connect capacitors or ESD diodes, and then a resistor circuit over here that can be reconfigured to simulate any number of sensors. We also have the 2 I/O lines are broken out and connected to a NTC temperature sensor and some other resistor networks for different testing options. And then this board just goes and connects on top here, and we are ready to start some testing. Alright, now I could either put in a coin cell battery if I had one around, but I'm going to go ahead and just plug in a external 1.5 volt supply. And let me get out my smartphone, and I'm going to open the RSL Central app, and we will scan and see, oh, there it is, the CEM102 demo board. Hit connect, and we should see some data pop up. So at the top here we have the RSL15 battery level. This comes in every few minutes, so don't worry that it's a 0. Below that we have the CEM102 battery level. However, this is actually being powered by the RSL15's internal boost converter, so 2.57 is about what we would expect, not the 1.5. Underneath that we have the temperature being reported by the CEM102 using the external temperature sensor on our sensor emulator board. And below it we have the voltages and currents being reported by our electrode. If we want, we can select the temperature or current to see a log and graph of our readings. Now these are coming in at about 1 every 8 seconds, so I'm going to go ahead and jump forward in time to collect a bit more data. Okay, so let's take a look at the temperature data and see what we got. Okay, so first of all, yes, it is a bit chilly where I am recording in my basement. But what's interesting here is we can actually see my air conditioning turning on and off. So obviously a quick drop as it turns on, it's slowly rising, and then it's dropping, rising. So that's pretty neat to see. Now our current sensor data isn't quite as fun to look at, but that's by design. This should hopefully be a flat line, but really what we're looking at here is just the noise in our measurement. And based on this, we're seeing measurements that only deviate by a matter of tens of picoamps. So I'd say we've got some pretty stable measurements coming in here. Alright, but then one last thing before we go, since I've already got it all hooked up, I can actually take a look at the current being consumed by our device right now. So let's take a look at what's going on. So if we zoom in on this portion here, what we're looking at is actually the CEM102 turning on to take its measurements, where we're seeing the current is bumping around at about 1.5 milliamps. Now if we move on over, we'll find the RSL15. This is its wake up and transmit period, where we can see the larger spikes up at about 9 milliamps for the radio transmitting data. And in between the two of them, we can see the current is falling down to about 18 or 20 microamps. So that is the low power idle state for the two devices coming in there. And one last thing to take a look at, if I press the user I/O on the board here, I'm actually going to put the RSL15 into a deep sleep and we'll turn off the CEM102. And now, of course, it's going to disconnect from my phone, so that's why we see we've lost our connection there. And if we zoom in, we can now see rather than the 20 microamps we were at about before, we're now around 350 nanoamps. So that is pretty low power. That will be all for today's video. Please stay tuned for more in the Getting Started with CEM102 series. And you can check out our website at onsemi.com for more information on the CEM102 analog front end, as well as the RSL15 Bluetooth 5.2 secure microcontroller. Thank you and have a great day.